Making sense of specialized engineering knowledge is not easy. A majority of the technical know-how is actually learned informally on the job and by doing. If you're fortunate enough, you've had an incredible mentor who's shown you the tricks of the trade. If not, don't worry about it, because this podcast will serve as your own personal tribe of mentors. In each episode, we will extract the tribal knowledge from top engineering and manufacturing leaders to help you on your journey. There's really no way of knowing what information you're going to need around the next corner of your career. So let grinding gears be your guide. Hello, everyone. Happy holidays. It is December 15th, 2019. Welcome back to Grinding Gears. My name is Bassanio Peters, founder and CEO of Assist to Develop, and I'm your host. We haven't put out an episode in a while just because we're working on some exciting things with Assist to Develop, but I'm very pleased to have Travis Jacobs here with us today. Travis, why don't you take a moment, introduce yourself, tell us a little bit about what you do right now, and then we'll just get into a conversation about our topic today. And for our audience, what we're going to talk about today is a little bit of Travis's background like we do in most episodes. But then what's really exciting is he put a blog post out recently and it has almost 1 million views, and it rightfully so. It's the 7 deadly sins of product development. And I've read it myself, obviously, and it's a great read. We're going to talk through some of that. So some people that are senior engineers in the room, managers, or if you're a student at a university getting ready to enter the engineering workforce, this is very, very useful information. So we're going to dive directly into that here in a moment. But first, we wanted to introduce Travis and get a little bit of background. So Travis, go ahead and introduce yourself and tell us a little bit about your story, including, dude, I got to hear how you got the nickname Travis Grizzly Jacobs.
Yeah, so Travis Jacobs started a company, J Simulations, a couple years ago. In a nutshell, we help companies develop products, get to market faster, avoid mistakes, costly mistakes, and been doing engineering for 15 years now, and I have seen quite a few mistakes, and the article we'll be discussing is kind of the biggest mistakes that are made on product development projects. So the funny story, the nickname I got from my older brother when I was 12 years old. We were fishing out in the mountains in Utah, and conversation that we had, and he started calling me Grizzly after Grizzly Adams, and been that ever since.
Funny. Got a long story that we don't have time to get into now, but all of a group of friends of mine that we all worked at a SolidWorks reseller together years ago. And every year we do a guys trip. And, this year it's actually in Jackson Hole, Wyoming. But looking forward to that. They all call me the bear, but we'll save that for another day. Travis, tell me a little bit about your backstory. I mean, one of the things that we do on the podcast here is talk about how you got so passionate about engineering. Was it something that you picked up early on as a kid? Tell us a little bit about your story and what got you interested in engineering. And then obviously you have your own freelance practice now. What drives you today? So what are the things you like most about the field of engineering?
Yeah, so ever since I was a little kid, 12, 13 years old, always been interested in how things work, take things apart. Sometimes I didn't get them always back together. So, parents would always give me stuff that didn't work, broken clocks, broken blenders, broken something, go play with it, take it apart, see how it works. So that's kind of ever since I was a little kid, always kind of had that knack, if you will. And I guess I'm one of those weird people that may be wired a little bit differently, but I look at something and I can always tell you at least 4 or 5 ways how to make it better, whether it's better performance, better usability, whatever it is. So that's kind of the passion and where it comes from.
How'd you discover that you had that knack? Like, what was the moment that you were like, holy crap, like this is something that I actually just have a knack for and I'm built a little bit differently. Can you talk about how you kind of discovered that early on?
So I grew up in Salt Lake City, Utah, spent a lot of time outdoors, fishing, camping, backpacking, hiking, mountain biking, whatever it may be. And I'd always be like sitting on a ski hill or, fishing in my favorite spot on the river. And I'd look at something and I'd be like, man, why did they design it like this? Why did they design it like that? It would be so much better. And that's kind of where it stemmed from early on, when I was a young kid of, why didn't they do this? Why didn't they do that? Or if I was an engineer, that's what every little kid says, right? When they're young. If I was an engineer, I would do it like this.
Okay, so fast forward to a little bit into your career. I mean, you've obviously worked at various different places from, Spirax, Sacro. Looks like you spent some time at Sierra Nevada as well. Can you give us some real world examples of that? Like where, maybe, and again, confidentiality is everything. So you don't obviously want to expose some product designs and stuff like that. But if there's something that you can share that maybe one of your favorite projects and something that you got really excited about because you were able to find a unique solution a problem. Can you share a little bit of color on that?
Yeah, so I spent, as you mentioned, I spent many years doing aerospace and defense projects, for all the big guys, which, that list is quite long, and gained a lot of incredibly valuable experience. And I would put those in two buckets. There's the what not to do, and then there's the what to do. And I'm incredibly grateful for all the years I spent on defense projects. That's where I learned how to do simulation and analysis, really learned how to use SolidWorks, Nastran, ANSYS, those tools, which are incredibly valuable. But what I learned is if you don't know how to use any of your tools, it doesn't matter how many tools you have, which is kind of one of the topics in the article that I wrote. There's a lot of that.
Yeah, sorry, I was going to say, that was definitely one of the topics, and I think the topic title is like the scalpel is only as good as the surgeon who uses it. So we'll get into that here in a moment. I know that's something that is near and dear to a lot of people's minds, is especially the 7 deadly sins of product development. So we'll get to that here in a moment. But you're obviously an independent consultant now and working for yourself, and many of our members that assist to develop maybe are moonlighting and doing work on nights and weekends and want to be able to expand to a freelance practice. Can you kind of help me understand like what it took for you to get started and, obviously share the good, the bad, the indifferent of, working for yourself and being an independent consultant, but kind of walk us through that journey of how you got started. Was it, you picked up a couple of contracts on nights and weekends and were able to sustain yourself? Help me understand a little bit more about how you kind of got started with JA simulations.
So I always wanted to do my own thing, even in high school, college, whatnot. And so there's always this little voice in the back of my head, or how do we do this? How do we make it better? How do we do it better? And for the first 10, 12 years of my career, I didn't feel that I was qualified, or maybe I didn't feel I had the experience, the expertise, the skills to do it. And then, so I was working for an industrial company, and things happened, and they moved product development elsewhere. And I thought, now's the perfect time. I have the skills, I have the experience, I have the expertise. Been doing this for 10, 12 years at that point. So I started thinking, if I was in charge, this was always the thought in my head. If I was in charge, what would I do, or what would I do different? And there's an article that I wrote recently. It's called the CEO Challenge, which kind of that's where it came from. And the article we'll be discussing today was kind of the first very popular article of how that thinking started, of what are all the mistakes, all the roadblocks, all the threats and landmines that typical product development projects run into.
So I want to back up for a second to something you said earlier. You talked about when you first were kind of getting started, you didn't feel like you had the skills and the expertise yet to be able to kick things off. But then obviously through your years of experience and work, and obviously through trial and error, you discovered, hey, look, I do have what this takes. I can branch out and do some things on my own. But how did you get over that learning curve and that hump to the point where you felt like you were confident enough? Was it just primarily experience and diving in and getting involved in some of these projects and then learning on the fly by making mistakes? Because that's typically how we all learn. Or was it you had a mentor or someone that kind of took you under their wing and really kind of showed you the ropes? Can you kind of give me a better understanding to how you gained the confidence to be like, I can go on my own and I can do this?
Yeah, and part of that is, it's a personal thing, right? There's a little bit of maybe ego, humility, expertise, experience, whatever you want to call it. It's kind of personal to each individual. It depends on what you're doing. So for me personally, it was, maybe a little bit insecurity or lack of self-confidence. It's like, well, I'm not ready yet. And then perfect storm happened, and it's like, well, ready or not, let's go. And I spent, 4 or 5 years at a industrial company making industrial flow products. And that's when I really became kind of, in my opinion, I really became incredibly comfortable using a set of tools, specifically ANSYS tools, of how do you use this tool to get to market faster, to reduce cost, find problems, and not just at an engineering level, but all the way up to the CEO level at a strategic level of how do you use this tool to develop products, get to market faster ahead of your competition and reduce cost. So that's kind of where the culmination came from.
Right. And I can 100% relate to that. Not feeling like you're ready, not feeling like you're confident, because how I launched Assist to Develop, it was honestly, I was selling SolidWorks software at the time. I was working for a reseller, and people would come to me, and this is right around when a few years after the economy had turned, and people had come to me and been like, hey man, I know you sold me SolidWorks before, but I'm out of work. Do you know any companies hiring any independent contractors right now? Because at the time, there was a ton of layoffs. So a majority of the hiring that was happening was just purely independent consultants and contractors. So I would connect these people with companies in need of their services. And it was just something that I kind of did. And, helping some friends out, right? I established relationships and friendships with a lot of these engineers that I sold software to, just because that's just my nature in business development and the way that I work. And in those relationships, I was, just basically finding them work. And then one of the guys was like, hey, Sanio, I think you could literally turn this into a business. Like, there should be a marketplace out there that connects some of these top engineers to people in needs of services. And most of the marketplaces that exist right now are a race to the bottom. So I'm not going to be able to find quality work without, dropping my cost dramatically, which I can't afford. I was living in Southern California. So, majority of the engineers I'm working with, had a higher cost than, let's say, someone overseas. So I didn't feel like I was ready yet, but I just kind of took the leap of faith and said, all right, I'm going to do this, and started out as just a consulting service, and it's evolved into what it is today. But definitely something that I think I can relate to, and many of the listeners can relate to. You don't necessarily feel like you're ready. However, you have the skills, the expertise, and the knowledge as an engineer to truly solve problems. And that's what it comes down to. And, the lean startup methodology is really just get out there, put products out there before you think they're ready. But obviously in engineering, you need to make sure that you're testing these products, like you said, especially for ANSYS, testing for different failure modes. But as far as launching a freelance career, it's just, maybe start just doing some moonlighting nights and weekends, and then grow and build from there. But next, Travis, I want to get into the meat and potatoes. Again, you have almost 1 million views last time I checked on the 7 deadly sins of product development. So I'm going to direct you guys in the show notes. I'm going to have a link directly to this blog post. It's actually quite hilarious because he includes a lot of cartoon graphics to explain each scenario. So Travis, let's just go through this one by one, because I think it can be really useful and really helpful, like I said in the beginning, for someone that is a product development manager or an engineering manager or director at an organization, an engineer themselves, or a student getting ready to enter the engineering workforce. I think everybody can benefit from this knowledge, hence why this has almost 1 million views already. So let's talk about this and break this down. So can you walk through, and it'll be conversational, just walk through some of these deadly sins of product development. One being, it sounds pretty interesting, and we'd love to hear how you're going to explain this. But number one is the pregnant woman theory. So kind of break that down for our audience, what that means, why'd you use that analogy, and what have you seen in your years of experience when companies are kind of faltering?
Yes, so set the stage. I like to tell stories. People relate best to stories. So to kind of set the stage, think of a bunch of executives sitting around the table, board meeting. Let's call the company Acme. CEO walks in and says to his board, says, "Guys, we have a problem. Sales are dropping like a rock. So what we need to do is we need to invent a product that everybody wants to buy." And they all, look at the CEO with this visionary leadership and say, "Man, you're a genius." So the CEO leaves, and the senior executives go talk to the engineering manager, and he says, "Well, we need you to develop a new product for us. How long will that take?" Hence, we begin the 7 deadly sins of product development. Incredibly common in many companies. I've lived it many times. It's incredibly hilarious after the fact, from the outside looking in. From the inside looking out, it's it's hell. So we start with the pregnant woman theory. In a nutshell, the pregnant woman theory is if one woman can make a baby in 9 months, can 9 women make a baby in 30 days? And you'll probably laugh. The idea is that I always say the battle plan's always the first casualty of war. So what happens when, you have a team of 30 engineers and they encounter a problem, which always happens. They go to their manager and maybe their manager goes to his boss. And the first thing that everybody always says was add more people to the project, which usually never works out well. So in a nutshell, that's the pregnant woman theory. When you're behind schedule, add more people, add more resources, and you'll get back on track.
Right. I mean, I'll be honest, that's been kind of some of the lifeblood of the business for us at Assist to Develop early on is, people are behind schedule and they're like, hey, we don't need to hire a full-time engineer right now. We just need someone, contract employee that we can work with and, they can work remotely, but trying to kind of help us get back on schedule. And oftentimes that's what happens. But the companies that succeed in leveraging our services, obviously you can get the help you need. The companies that succeed in getting back on schedule have clear plans, clear visions, and understand the specific tasks that these people need to do to get back on schedule. If you're just, it really comes down to the planning up front. And if you're doing things improperly, if I hear you correctly, you're doing things improperly from the jump and from the planning period, then as you go through development, if you just throw more resources at people doing things the wrong way, then you're going to still run into the same issues no matter how many people are on staff. Do I understand that correctly?
Absolutely. And this is where this theory can be incredibly nuanced and it takes a bit of experience and wisdom, whatever you want to call it, to understand this. Look, you can look at it. I use a couple of different analogies. One of them is a pregnant woman theory because that's a natural process which everybody understands. Or like a farmer, if you want to harvest corn in October, you should probably plant in the spring. You can't show up in September and say, hey, I want to harvest corn in October. Let's speed this up. Let's hurry this up. So that's one analogy. The other one is think of Henry Ford, in the 1900s when he invented the assembly line. So what he did was he's like, that's a planning and organization. That's a strategic thing, mindset, whatever you want to call it. It's like, oh, well, I can increase efficiency by having workers do different things, which obviously works incredibly well. Where this falls apart is think of it this way. If you hire an artist to paint you a picture and it's like, hey, I want you to paint me a picture of maybe some mountains, maybe something scenic. So the artist says, okay, it'll take 2 weeks. So 2 weeks later, he's still not done yet. Well, it's going to be another couple of weeks. So in that situation, having 4 people paint the same painting doesn't work. That's where it falls apart. So you have to know from experience, scars, bruises, and lumps of, is this a violation of the pregnant woman theory? Or can we use kind of Henry Ford's model to speed this up? And that's the trap that people fall into is we're behind schedule, throw resources at it. Sometimes it works. Most of the time it doesn't.
Yeah, and I also think it's a byproduct of people at the top, right? In a previous episode, one of my guests who wrote the book, The Making of an Expert Engineer, his name is James Trevelyan. He told me that a lot of engineers don't understand what are the things that create commercial value for customers, right, and clientele, and then the CEOs and executive management at the top don't necessarily understand what all the engineering team is doing. So poor planning from the jump is an issue, but then also being super reactive to the market, right? Saying, hey, products, and we're kind of faltering in sales, not being proactive and trying to get a better understanding of, okay, what do our customers want? How is our customer evolving over time? What trends in the industry are really pushing, our products to change or making us take a look at our products and figure out things that need to change. Oftentimes, way too often, people are just being reactive. So I think that's a good point. The next one that number 2 I see is, one of the things that you outlined is it's stepping over a stack of $100 bills to pick up a penny. So can you kind of walk through this? And again, I think it'd be great if people kind of follow along in the blog post, which again is in the show notes. So if you have the chance, go ahead and take a look at that. But can you kind of explain this theory a little bit? Kind of again, this is kind of the next step in the process. So can you kind of explain this to our listeners?
Yeah, so I've seen this happen more times than I can care to count. The two probably most visible examples that I can think of are you're working on a project. It's Friday afternoon at 2 o'clock in the afternoon, let's say, and you may be running 1, 2, or 3 shifts, maybe 24 hours a day. So you've got a crew coming in, you got third shift coming in a little later, and you got a crew coming in on Saturday. So the engineers, the manager, whoever says, we are out of bolts or we are out of these parts. So what do? They order it online, they order it from whoever, and they need next day air, UPS, early AM Saturday delivery for these bolts. So you're spending $400 in shipping and maybe $100 in parts. Typically what happens is those bolts are still sitting on the shelf 2 weeks later. And this happens day in, day out, many times a day. So that's one example that I've actually seen. The other example is, well, we've got these prints. Send them to a machine shop. We need them, have them made. Well, the prints aren't any good, but we don't have enough time to, spend another 2 hours making these prints good. So you send them to a machine shop. They make them. So it's $2,500 worth of parts. You get them back. They're garbage. And that's usually where they end up quickly. The other example is more from a labor perspective, and I've seen this happen as well. The fabricators, the technicians, the guys on the manufacturing floor putting together your product go to the engineer, to the manager, and say, "Hey, I need this set of tools. It's going to cost, say, $1,500." And the first thing the manager says is, "No, that's too expensive. We can't afford that." And so then the technicians, fabricators go back to the floor, and it takes them 10 times longer to do it manually because they don't have the right tools. Does that make some somewhat sense?
Yeah, absolutely. And I can give an example from, like ANSYS or simulation tools, for example. A lot of times people are more comfortable doing hand calcs, but hand calcs may take a lot more time. And that's where simulation tools like ANSYS, SolidWorks Simulation, and some of the other high-end tools out there play a really big role in product development process, because especially if you can introduce a simulation driven product development process, it makes it a lot easier to quickly analyze and see, okay, this product is going to fail. And if we add this type of material or use this type of material on the product, it can strengthen it a bit, and make it easier for us to produce and, monitor costs. That investment, up front to buy the software will pay for itself over time. But oftentimes, I think that's a good example of, number three, which is champagne on a beer budget, where it's, people expect, managers, middle managers, which then, engineering managers and directors are trying to go to their bosses, executive leadership, and say, here's the things that we need to spend to make sure that we can get products out the door faster and more accurately. And then obviously the biggest thing is to reduce scrap, reduce waste in your product development process. But challenge often becomes like, hey, look, we just don't have the budget to spend on this tool. But then you end up wasting that same budget anyway in your product development process because it's not streamlined, for one. And then number two, there's a ton of scrap or waste just because you're doing things improperly. And that's a good example of number three, which is the champagne on a beer budget. Can you walk through, this is the really good one that we kind of alluded to early on. The scalpel is only as good as the surgeon who uses it. Not all tools are created equally. And I want to talk about this and elaborate on this because, especially for freelancers, look, it's some of these CAD softwares and some of these tools are expensive, right? They're expensive out there, but you need to make sure that you have the right tools to be able to complete the job. No knock on some of the other tools that are out there, but you probably want to use some more best-in-class tools as an independent consultant and freelancer if you can find a way to get them at a obviously reasonable cost. But again, the tools are great, but you also have to be an expert practitioner in being able to leverage those tools. So can you kind of explain some examples of things that you've encountered in your career and kind of seen that where, again, it's really a matter of, listen, you got to make sure that you're proficient with the tools that you use every day. Can you kind of explain that and give some real world examples that you've seen?
Absolutely. Going on the simulation theme, I can't tell you how many times I've heard from clients, customers, or even from my own experience in companies I've worked for. You go buy these high end simulation tools, which are incredibly expensive, and I've seen there's usually two common pitfalls. So you spend $100,000 on simulation software, which is no small chunk of change by any means, and the two most common mistakes I see are, well, we just spent $100,000 on software, but we can't spend $5,000 to train the engineers on how to use it effectively. I've seen that happen so many times I've lost count. The other caveat is you got $100,000 worth of software running on a computer that's 4 years old that costs maybe $2,500, which to me makes absolutely no sense. It's the analogy I use is like you just bought a brand new Porsche 911 Turbo, you took the wheels off of it, put it on a trailer, and now you're towing it around town with a 1982 Ford Focus. Makes absolutely no sense. It's like,
right,
guys.
yeah, that's accurate. That's accurate, and I haven't seen someone throw a turbo on the back of a trailer, but I've definitely seen these real world examples, specifically the training aspect, right? Especially because all of these software tools evolve each year, right? They're constantly adding enhancements and improvements. So you have to honestly continuously try to improve as an engineer. And it's partially your responsibility, but it's also a responsibility of the engineering teams to empower their team members to be proficient with the tools that they use every day. So again, I wouldn't even say in that case, it's not even necessarily champagne on a beer budget. It's, you're spending on some of these tools and then not making the full investment. And then again, the scalpel is only as good as the surgeon who uses it. So that's a good example. Something that we always see in sorry, Travis, go ahead.
Well, just to caveat on the point you just made, you spend $100,000 on this tool. 6 months later, the engineering manager, the VP, or the CEO comes down and raises holy hell with the engineering manager, going, "We just spent $100,000 on this tool, and I see no benefit. It's your fault," which I've seen happen because they don't know how to use it. They don't have the training. They don't have the hardware. I mean, some of these computers to run this stuff can be $20,000, $30,000 just for hardware. So it's kind of a three-legged stool, if you will. You need the software, you need the hardware, and then you need an expert to run it. If you take out any one of those legs, the stool falls over.
Yeah. And I think that, obviously I've seen cases, everybody on the phone, I'm sure listening in to the podcast can probably relate. One of the other, matter of fact, number 5 is you can never run out of things that go wrong. Definitely Murphy's Law here, but tell me how you can, in your experience, and especially when it comes to, from concept all the way through production, what are some ways that work really well to obviously ensure that you're prepared for the challenges that you're going to face? And, how often have you seen managers try and just kind of stick their head in the sand and avoid and act like none of these challenges are going to come up? I think the more experienced people out there obviously know this, but for some of the younger kids coming out of school that think everything's going to potentially be smooth sailing, which I don't even think that's the case these days. I think educators are doing a really good job preparing students. And, if you're graduating with your degree in mechanical engineering, I mean, that's a feat in itself just because how difficult that is and the challenges you're going to face just studying. But can you kind of help me understand a little bit more about this point at number 5, where you can never run out of things that are going wrong?
Yes. So maybe just to take a step back for one moment, go back to number 4. My favorite expression is, and I say this all the time to clients, to executives, to people, and it gets the point across very well, is you can give a monkey a scalpel, but that doesn't make him a surgeon. And oftentimes in bigger companies, bureaucracy is kind of the enemy and can be a little bit evil and gets in your way, and it's harder to see in that regard. And the picture in the blog article, which is one of my absolute favorite pictures, is a guy trying to see over a 12-foot high brick wall, and he's got 20, 30 ladders piled up beneath him, and he's trying to stand on them to see over the wall. And this is kind of more maybe applies to more management than engineering. Effective resource utilization. It's more of a leadership kind of quality.
Yeah, because the image itself, for everybody that can't see it, the ladders, when you say 20, 30 ladders, you're like, how the hell is he not getting over and being able to see over the wall? Well, they're all laid kind of horizontally on top of each other in the image. So as you said, it's really about utilization of the resources and the people, and putting people in the proper position to be successful and to make sure that your products are successful.
Absolutely, which perfectly leads into number 5, you call it Murphy's Law. I call it you never run out of things to go wrong. And it's maybe a little bit of a leadership quality as well of, you get the manager maybe a little bit experienced from number 4 trying to stand on the ladders. And it's a human's natural tendency to maybe blame others. And so when you kind of point out, it's like, hey man, you need to use the ladder this way. There's a little bit of ego, maybe a lack of humility. And so when things start going wrong, really wrong, that the natural tendency is to, blame, finger point, scapegoat, which is kind of where politics, bureaucracy, red tape kind of all take over, and they start to work against you. And the other caveat to number 5, and this kind of leads into 6 too, is when you plan a product development project, you have this Gantt chart that's all pretty and all the tasks line up and you've got your predecessors and this and that. And think of it like a combat situation. Once the bullets start flying over your head, that Gantt chart goes out the window. Just like in engineering, your product doesn't work like you think it should. It failed approval. It failed a test. Your prototype doesn't work. Some major something happens. But the thing that is interesting is that in the planning stages, everybody thinks the plan is perfect, which is one of the biggest mistakes that I see in strategy and planning. The plan is perfect. We're not going to have any mistakes. We're not going to have any errors. I call it denial of Murphy's Law.
Well, I think that's part of the reason why, again, using the lean startup methodology and just lean and product development, you want to be able to, and this is where simulation and 3D printing, can play a huge role, where you get in, you build, test, iterate, right? So build, test, iterate, and you're going through this constant cycle until you get closer to the design that you're actually looking for and the product you're actually interested in. And I think that's where the lean methodology plays a huge role, but then also a simulation-driven product development process where, maybe not everybody's packing $100,000 worth of ANSYS tools, but that's where I think tools like SolidWorks simulation play a huge role, right? But they're not as precise as ANSYS. And I know the SolidWorks folks aren't going to be happy to hear me say that, but the reality is they're not as precise as some of the more high-end tools. However, that's not necessarily where those tools play. Where they play is, hey, look, I can get closer to the answer that I'm looking for. And if I have everybody on my team or a larger population of people on my team using simulation tools as they're developing their product, it's not like, hey, look, let's pass this off to Jim, who runs all the analysis, and wait for Jim to come back and tell us that this part doesn't work. If they're part of the design process, you're actually testing and iterating along the way, then you're going to get to the right product faster. And I think that's kind of an important role that people need to add in the planning process is, hey, look, we should be testing, not have this long drawn out plan, because again, like you said, once the bullets start firing, all that stuff goes out the window.
Yeah. And so 2 points. One of my favorite leadership books that I just finished reading ever is by a retired Navy SEAL commander, Jocko Willink. He spent 20 years as Navy SEAL commander. And when you're, a Navy SEAL, the best of the best, special forces, their whole plan or how those guys operate is all centered around Murphy's Law. And they plan for it from the get-go. We know things are going to go wrong, and they plan and they train for months. We know, here's all the things we know that can go wrong. And this is just what we know. But here's all the things we don't know. And so when you're in that kind of fog, if you will, you don't know what you don't know. And product development falls into that category. It's kind of stumbling through a hiking trail or a mountain pass, at night with no moon or blindfolded. You're kind of stumbling around. You don't know where the edge of the cliff is. And the biggest mistakes that I've seen is when, I call it denial of Murphy's Law. When you deny that there's threats out there, when you deny that there's the edge of a cliff, that's when you set yourself up for the biggest fall. So if you know that things are going to go wrong from the get-go and you plan, you prepare, you have contingencies, you may think that you have 90% of the facts, the data, and information going in. And then 3 months later, you look back and say, wow, I only had 10% of the information that I need. So if you think that way going in, and, like you said, it's all about iteration, fail fast, fail often. And that's where simulation comes into play. You can run 100 models in a day day and figure out everything you don't know.
Right. And that kind of leads into the last point, which, we're coming up on time. So we'll end here. Respect everybody's time who's listening in. These are more long format episodes because we're getting into a lot of meat and potatoes, but definitely want to be respectful of all of our listeners' time. But this gets into the last point, and I'll just read a quote from the article. We never have time to do it right, but we always have time to do it over and over and over and over. So this kind of dovetails from the last point, which is like, listen, if as a part of your plan, you're saying, hey, listen, things are going to go wrong, right? We're going to have issues. We're going to have times where the product's not performing properly. So let's introduce this lean methodology into our product developments where we're not afraid to fail. We iterate, we make the necessary changes and move on. That to me is how you go from, instead of having 7 to 8 prototypes, maybe by introducing this process, you can cut it from 3. But the 7th point in the 7 deadly sins of product development is good, fast, cheap. Pick any 2, right? We hear that often, but explain to us what this means specifically in engineering.
So, to be brief, we kind of lay out a 3-stage process to product development. Step 1, I call the napkin sketch. It's literally 2 guys sitting in a bar, you have a napkin sketch. And so it's ideation and concept. So tools like SolidWorks Simulation, ANSYS Discovery Live are perfect for this. It's the baling wire and duct tape methodology of, does this work, yes or no? And it's binary. It works or it doesn't. You're testing physics. Step 2 is more virtual prototype. So this would be like a full-blown 747 in in ANSYS software testing the fluid dynamics. It's very accurate. So step 3 is production, manufacturing support, or a digital twin. So those are kind of the 3 buckets. So the mistakes that people make is everybody wants it fast and cheap, right? Especially in engineering and somewhat manufacturing. So the caveat is, I want it fast, I want it cheap, but it's not any good. It's poor quality. So you got to do it again. But to do it good and fast, well, that's too expensive. We can't afford that. So instead of spending, say you spend 50 grand once, you spend 5 to 10 grand, 6, 7, 8, 10 times. So it's more expensive in the long run to do it fast and cheap than it is to do it fast and good in the beginning. If that makes any sense. And I see it a lot in product development. You're trying to rush the process because you're on a budget, or you're behind schedule, or a competitor just beat you to market. But trying to do things too fast on the cheap is the most expensive way to develop a new product.
Yeah, wholeheartedly agree there. And I've seen it too many times, and that I'd like to count. Travis, again, thanks for your time. Much appreciated. We're doing this on a Saturday afternoon. I have little kids and they're not here today, so I was able to record the episode at home today. So thanks again, Travis, for taking the time. Again, in the show links, we have a link to this actual blog post called The 7 Deadly Sins of Product Development. And then also we'll have a link to Travis's company, JA Simulations. So if you have any additional questions, you need some simulation support, this is definitely a freelancer contractor that we vouch for here. So thanks again, everybody, for tuning in, and look forward to a couple of new episodes outside of this one dropping here pretty soon. So happy holidays, everybody. Enjoy the holidays with your loved ones, and let's kick off 2019 strong. Thanks.
Thank you.